everybody, and welcome to this special edition of the Ampere Developer Impact. The Ampere team was on site in Salt Lake City, Utah for KubeCon North America 2024. We had the opportunity to meet a number of our ISV and operating system partners to talk about what's new in the cloud native ecosystem and how they've been working with Ampere. So without further ado, here are some highlights of the conversations that we had at KubeCon North America 2024. Enjoy. We talked to Vijay Kumar of Oracle about how Oracle have been supporting the CNCF with cloud credits for ARM compute powered by Ampere. And we also saw a demo of how the CNCF is using those credits to enable the use of Kubernetes for dynamic GitHub Actions builds.
Last year, we announced $3 million per year for 3 years of ARM credits on Oracle Cloud Infrastructure, so that the CNCF projects or open source projects can use to build any open projects that they want. And we're happy to report that this year, we have several projects that are already onboarded and they're running on OCI. Major projects like Kubernetes, Crossplane, NATS, OpenTelemetry, and others are actually running on OCI and taking advantage of it.
A demo that we're running where you can run your builds for GitHub. We're using LLVM as a sample project just to show this working, but you can set up OKE Kubernetes clusters to do all of your GitHub builds. So the point is, it's really easy if you want to do bare metal builds on Ampere hardware for GitHub projects. It's really easy to get that started. And in fact, this is the same technology that Oracle is using to make Oracle credits for ARM64 instances running on Ampere available to CNCF projects.
Several Ampere partners had Ampere hardware on display on the show floor and talked about how important ARM64 support was for their product portfolio. We also talked to System76, a hardware partner who made many of the units that were on display.
Been collaborating with Ampere for the last handful of months, developing the all-new Thelio Astra, which is a release formally yesterday, using both Ultra and Ultra Max CPUs, up to 500 gigs of RAM, and single NVIDIA 6000 ADA GPUs on it. So it's a lot of compute in a box, and providing a streamlined developer solution for people looking to use ARM-based systems for their next compute challenges. Yes, so a lot of the stuff that we've been doing is, for the start of the project, was geared towards the automotive industry. So we've been working with the team at Ampere, partnering with other projects and other organizations in order to try to understand workloads, make sure that the hardware and the software are all coming together in order to provide the right solution for the right task. In this one right here, we've got the Ampere M12830 with 128 gigs of memory, quad channel with a terabyte M.2 PCIe Gen 4 drive, and this one has the A4000 NVIDIA graphics card, but that's the starting unit. And like it said earlier, you can upgrade that up to the 6000 ADA. And the real big benefit here is chamberized cooling. So that's one of the big things associated with Thelio, which is designed, manufactured, and built all from our factory in Denver. And you essentially create a path of cooling for the CPU as well as the GPU that's all controlled inside through the ducting system. And you allow full thermal process. There's a GPU brace. So you can expand and draw. You've got more PCI lanes as well for expansion, and up to 512 gigs of memory, all within this small, I think it's 36 or 38 volume for this chassis, running extremely quiet, extremely efficient throughout the entire system.
New this year, we have ARM support for Rancher and Harvester. And so we've got an Ampere cluster that's running Harvester, so you can run virtualization on top of Kubernetes. And basically that gives you your hypervisor platform, your containers all in one location. And it's running on an Ampere server back at our office. And then we've got this one here that we're showing. That's a nice flyaway kit. So we have, especially some government customers, things like that, they need to be able to bring their server with them with all their load and everything on it. It can't leave their side, so the purpose of that is designed so that it can fit in a carry-on space. So you can carry it on, throw it up in the overhead bin, and bring your server with you. It's got wheels, it's got a handle, so it makes it nice and easy to make it portable. And it's got, I believe this particular loadout has 300 and some cores, a couple terabytes of RAM, ton of hard drive, so you can really load a large workloader, bring it with you wherever you need, and have everything at your fingertips.
So this is all running on ARM64 on Ampere?
All ARM64, Ampere.
The use of WASM or WebAssembly for cloud-native workloads has really increased in recent years. And one partner, Fermyon, showed how Ampere hardware is powering this new generation of cloud-native compute.
We've got a couple things going on here. We have a System 76 box where we're running our demos. We have a little screen attached to it here. And that's just great because we have a highly dense compute platform for WebAssembly, and having some extra horsepower just really brings our demo home. And then we also are partnering not only with Ampere, but with Microsoft and Akamai to do a multi-booth demo here at KubeCon, where we're using sound as a proxy for booth engagements. So we have an Arduino device at every booth that sends volume levels to a centralized MQTT broker. And then we have serverless WebAssembly applications that are responding to those events from the MQTT broker and persisting the volume levels at each booth. And then we have an entire full stack WebAssembly application that's displaying the volumes at each booth. And the idea is like we can see which booths are getting the most engagement at any time. And you can enter a raffle to win.
We spoke to operating system vendors Suse, Canonical, and Red Hat about how important ARM64 is for their product portfolio and how they've been working with Ampere to support customers who want to run on that platform.
Yeah, so we have a AI desktop in which we installed Suse virtualization based on Harvester. And then up here we have an Aero 300 from HP that we've integrated also with Suse virtualization. That is connected to our Rancher instance, which we use to deploy our virtualized Kubernetes cluster. You can deploy your containers on the bare metal level, on virtual machines, and of course just run traditional VMs as well.
We realize that a lot of data centers are beginning to implement ARM processors and chips in their servers, and we obviously want to make sure that Linux is there and that OpenShift is there to support the workloads that they need.
And we have some common customers, right? We have Red OpenShift customers that are running on Ampere processors. Can you talk a little bit about?
Yeah, so one of the probably big ones that everyone's heard about is Amadeus. They spoke at our Red Hat conference called Red Hat Summit several years ago and explained how they're using ARM architectures inside of OpenShift as well.
AI was everywhere this year, and we talked to several partners about the importance of AI inference as a use case and how Ampere has provided best-of-breed price performance for that use case.
It's interesting to look on how Canonical and Ampere are working together to enable organizations to run their ML workloads. If you ask me, the next big wave is coming around AI at the edge, and that's where Ampere's hardware, together with some of the software stacks, I'm not sure if you can see it here, but it includes basically Ubuntu as the operating system, and then on top of it, we add Kubernetes for container orchestration, as well as the optimized framework that Ampere has to run models at the edge. I think that's where it's interesting to see how we are solving the problem, how we are actually moving beyond just developing models, and also how we do it in a secure and scalable manner. One thing that often organizations don't talk about that much is how you need scalability even at the edge. When you run the model, you need more resources. But when you don't run the model, why not free up those resources so you ensure that other workloads can easily run as well?
So we are part of the Ampere AI Platform Alliance, and we're really excited to be here with Ampere at KubeCon. And we're demonstrating our AI processing pipeline end-to-end. So ingesting data for customers in their enterprise environments, processing it for AI, and then chat inference, linking their data to open models that are available on Hugging Face and Olama. And for a customer that has very little experience with AI, we can be up and running in 10-15 minutes. So for savvy developers, we also provide our full SDK and API at docs.vue.io. So you'd be able to leverage any of our microservices and integrate that directly into your AI processing pipeline, your AI application.
And have you seen any interest for view systems software running on ARM64 and on Ampere specifically?
Absolutely. And one of the real big benefits is you do not need GPUs for chat inference. And when people think of Gen AI, they automatically think they need GPUs. And since we're not doing training of models, we can actually use Ampere's 128-core, 80-core ARM processors to do the document processing, the ingestion, and chat inference. And that's what we're here demonstrating.